So, first of all, thanks everyone for being here. My name is Felipe, my colleague Georgi here. So, we'll be presenting ABRIS, which is this Avro bridge for Spark. So, before we get into the main subject, we should mention that we work for ABSA, which is this Pan-African financial services provider. So, we are part of the big data team. We are big data engineers in the research and development team in the big data space. And we try to fill some gaps that we find in the Hadoop ecosystem, but of course, always based on the cases that we have inside the bank. Okay? And so when we find some of those gaps and we are able to fulfill it, we contribute it back to the community. So far, we have around 20 contributions to Apache Spark at this moment. And also we have this GitHub space. So we have a couple of projects there. ABRIS will be presenting here. There is also Cobrix, which is a data source for COBOL data for Spark as well. We have Atom, which is this library for data quality, also for Spark. And there is Spline, this data lineage tracking and visualization tool, which will also be presented here in other tracks. So please don't miss it. We should also mention that ABRIS was initially developed for Spark, not for Spark 2.2, but when Spark 2.2 was around. And specifically, we were working in creating this bridge for reading Kafka data in Avro format. And now we know that in Spark 2.4, there will be built-in capabilities to support Avro data. So that's pretty good. We are looking forward to contributing some of our core features into this version 2.4. But we still offer some features that Spark 2.4 does not. So we'll be mentioning that as part of our effort, we will be trying to make the APIs like seamlessly interchangeable in this sense, so that you can choose whatever makes sense for your use case. So getting into the subject now, the main motivation that we had to develop ABRIS was, beyond others, these four. So every time you need to get Avro data, you need to create a UDF or to implement some map functions in order to handle the Avro data. So you had to cope with schemas in that sense. That was one of the motivations. The second motivation was we had adopted this Confluent platform, Kafka platform, and there was no support for it because there are some details related to Confluent Avro data we'll be mentioning, so we had to implement that as well. We have evolving schemas. The schemas change all the time because it's a huge organization across like 14 countries. So we have to make everything interchangeable. So we have to change schema all the time. And there is no support in the community for this, for a centralized schema management, such as what we have in this schema registry. So we would like to make that part of the API as well. And finally, there was Databricks Spark Avro library, a very good one. However, it did not provide support for structured streaming, and we needed that. So because of that, we started to develop ABRIS. So from an architectural perspective, this is the problem that we had. So Spark is our computing engine of choice. Everything that we do is done on top of Spark. And then that's the problem that we faced. So Avro data coming into Spark, and also Avro data coming out of Spark, and we having this connection managed by schemas, of course, the format for the data, but it should be part of the whole thing. So this is where ABRIS fits in. Like it gives you these functionalities. So it doesn't have to be Kafka, it could be other sources, but the point is, if you have Avro data and you want to get it into Spark in the structured APIs, so you can use ABRIS. If you have data inside the structured APIs, like a data frame, you read it from Parquet, for instance, you want to convert it into Avro, you can use ABRIS. If you want to change the schema on the fly, you can use ABRIS as well in integration with Schema Registry. So going deeper into what we created, this is pretty much the problem, right? So if you're looking at the problem from ABRIS perspective, basically what you have is, if you have a data frame, like this data set of rows, and you want to convert that to a data set containing Avro payload, this array, a data set containing array of bytes with the Avro payload, use ABRIS. And the same, the other way around. And there are two main entry points in the API to provide this functionality. So assume that you're looking at this picture from the perspective of ABRIS. So if you're inside ABRIS, and if you call from Avro, that means that you're converting from a data set of arrays of bytes into a data set of rows. Okay, the arrays of bytes containing the binary Avro payload, and the other way around. So if you're calling to Avro, it means that you're converting from a row into an array of bytes containing binary Avro data. And also we should plug the schema management. Where is this schema that we are using to convert to and from Avro data? So to the context of this presentation, to the context of the value proposition of the API, we are bringing 5 main features, which are these, like ease of use, schema retention policy, which is about how you format your outmost data frame, the schema management, as I mentioned. Also, we provide support for Confluent Kafka. You'll be understanding why it's necessary to have this specialized support. And also support for Kafka keys, so it's a Kafka-related feature, okay? To explain the whole API, we'll be assuming this use case. So we have Spark producing Avro data and dumping it into Kafka, and on the producer side. And on the consumer side, so the other way around. You're consuming from Kafka in Avro format and getting the data into Spark. So the whole API will be explained from this perspective, the perspective of these 2 jobs. Okay, so Georgi will be explaining the API too.
Thanks, Felipe. So, okay, when we start using ABRIS to write to Kafka, we basically use this boilerplate code. We have a data frame that we call write stream on. We say we're using Kafka. We pass in the address and the topic name. And then we go start. Reading, same boilerplate. These are the examples that we'll be showing you throughout the presentation. So we're reading from Kafka at a specific location with the specific topic, executing a simple query, and writing it to console for debugging purposes. So when you use ABRIS, all you really need is, in the simplest case, a Avro schema to import. Where did this go? Okay, sorry. So, yeah. Import the library, and you call to Avro passing in the schema. It's simple as that. Reading likewise, you need the schema, you import the library, and you call from Avro, passing in the schema, as well as the name of the column where the Avro records are stored. And speaking of Spark 2.4, this is as far as it goes, the functionality that they provide. Anything that follows is ABRIS-specific stuff that we would like to offer above that. Now, there's a third parameter that you can see here, which is the schema retention policy, which I will tell you about now. It's basically ABRIS's way of asking, do you want to keep the original schema of your dataset, or do you just want the Avro records to become your top level representation? So in this example, we basically have a data set of Kafka messages, which are fundamentally key value pairs with some meta information like topic, partition, offset, and so on. So the values contain Avro records, which if we retain the original schema, just become Spark structs inside that column, or if we are only interested in that column, we can just pull that out to the top of the data frame. Schema management is a key feature for any organization that basically has more than one thing running at a time, right? So instead of storing your schemas in HDFS and hoping for the best, it's a good idea to have some tool like Confluent Schema Registry, which is open source and provides you with a RESTful interface to store and access all of your schemas in a backwards compatible way, handling all of the evolution management for you, which is why we provide this integration with it. To use Schema Registry with ABRIS, all you need is the settings, which are just where Schema Registry is located, the version of the schema, which is the schema ID. In this case, we're passing in latest, but you could pass in any specific ID that you want to use for the specific, in this case, consumer. And the topic. In Schema Registry, you store and locate all of these schemas based on the topic. So we have these settings, we import ABRIS, and we call from Avro, passing in Schema Registry this time instead of a specific schema. Now ABRIS handles fetching the schema from Schema Registry for you and spares you all of the headaches that go along with managing schemas. And so, yeah. Writing with Schema Registry is just as simple. Again, just the Schema Registry settings, you import ABRIS, and you call to Avro, passing in the topic name, so that when you register or update a schema, it can find it based on the topic inside Schema Registry. And that happens only if you provide the optional Schema Registry settings. And it updates it only if the schemas are compatible. So we could pass in the schema itself, or we could pass in the schema name and namespace, which allows us to infer the schema from the data frame and create the Avro schema with the schema name and namespace provided, which are required for any valid Avro schema. Now, a word about Confluent's platform, which we use inside our organization. In order to make the Avro records self-describing in a way, instead of appending the schema to every record, what Confluent does is it appends the ID to the top of the payload. So this is where it is. On line 86, you can find it happening. And this makes it incompatible with regular Avro deserialization that comes from the standard Avro libraries. So we handle this as well. And to do that, again, in the example, we're passing in the Schema Registry settings, because, again, schema management is important. We import ABRIS, and we call to Confluent Avro, so that we know to handle this specific case with the schema ID being appended to the top of the payload. Reading, same idea, just as simple. Schema Registry settings, import ABRIS, call from Confluent Avro this time. Let's now talk about some Kafka-specific things that ABRIS provides. So in Kafka, like I mentioned before, messages are basically key-value pairs. What the key is used for is for deciding to which partition the message should be sent. So the key and the value can both be Avro records. So to support this, we have both a key and a value schema. We import the library, but this time the API with key column, and we call again to Avro, passing in both schemas this time. Reading, again, the key and value schemas, import the library with key column, and pass in both schemas to the from Avro method. So in case you still want a distributed, a partitioned Kafka topic, writing to it with keys that are not Avro. We provide this plain keys API as well, which you only have the value schema. You import again with key column, but this time to Avro with plain key passing in the value schema. So plain key basically allows you to pass in any value. It will be transformed to a string, because this is Kafka's default serialization for key records. And we are basically done with the API. I'm sure you've all seen how simple it is to use. It's just the two methods, to and from Avro, over and over again. I think I hammered that point home quite well. And I will pass it on to Felipe now to give you some insight into the internals of the library.
Okay, so thank you, Georgi. So when we started to develop the project, of course, we didn't want to rewrite everything from scratch. That would mean like introducing bugs and stuff, and simply throwing away everything that is already available there in the open source community. And since we are looking for contributing, so what we did basically was we built this library on top of these 4 technologies mostly. So as I mentioned, what was motivating our use case was this Confluent platform, because this is our Kafka distribution. Also, the Databricks original Spark Avro library. Spark, of course, and the original, let's say, or official Avro library. So the idea here is to show you pretty much what are the components involved, the components that make ABRIS to work, give you an idea of what we have modified inside those components, what we have developed, like in terms of this infrastructure, and for those of you who are used to these libraries, so you can understand what's going on and refer to it at any point if you need it. So again, the whole idea is you can call to Avro and from Avro. That's the main idea. So in this example, we are basically doing to Avro because we have Spark rows, so the rows inside the data frame, and we want to convert those, or the content of that data frame, into an Avro payload, and then do whatever you want with it. Okay, so of course, the row belongs to Spark. We went to Databricks library, and we reused that class called Avro Output Writer that converts the row into this generic record. Generic record is the basic abstraction for an Avro record. You see, it's like key value based and contains the Avro data. So this generic record, we pass it through this binary encoder, which is also part of Avro original library, and then we have an array of bytes in Scala, so containing the Avro payload. So basically reusing and adding some code you see in some of the parts, but basically reusing and making the feature in this case. The feature is to Avro, so it solved our business case. This is the opposite. So we have an Avro payload, we are receiving it from Kafka, for instance, and we want to convert it back into a Spark row. So we pick the array of bytes in Scala, we pass it through this binary decoder provided by Avro's official library. We get this generic record again. So we pass it through our own reader. We created this reader that converts from generic record into a Spark row. And then we have from Avro. So the core of the library is implemented like this. These are the main components involved, so that if at any point you decide to play with the library, so you know the dependencies and stuff. So since this is a developer's track, we thought that it might be interesting to mention some points related to the code, what we had to do in order to have this all working. So talking specifically about, because you might think, okay, so Avro is this format, it's out there, so Spark is also out there. Why didn't we already have this library running, since Avro is like the default payload for this kind of task, like sending data through Kafka, through streaming and stuff. So why didn't it exist yet? So there are some details, some of the details are related to how you put the Avro library inside Spark. Okay, so basically, among several other things, I think that the most important abstraction that we can present here is these are the three main classes involved in generating Avro records. So this is specific data reader, specific data, and generic record. These three classes belong to Avro's official library. Okay, so specific data reader is kind of a deserializer for Avro data. The generic record, we have already talked about it. And this specific data is kind of a utilities class that provides some methods for you to facilitate the manipulation of those generic records. So we extended these three classes in this specific case. And what we did was something like this. So we extended this method read string. Why did we do this? Because Avro has its own string representation. It has its own string object. And this object is not recognized by Spark. Spark doesn't understand this object. So we wanted to convert it to a string on the fly. The same applies to array. Avro has its own array representation. So we replaced it by an array that belongs to Scala collections so that Spark can accept it and play with it nicely. The same for maps. So talking about generic record, the usual way, if you think about it, you have this generic record and it can have several other layers of nested structures inside it. So the way it was implemented in the solutions available in the open source community, at least the ones that we checked, was like this. You recreate the whole record and then you go inside the innermost record and it starts to unwrap it. So you parse all the records and then you unwrap it. But we thought that it would be much faster, and actually it proved to be much faster. If you fail fast, so if you cannot convert one record, you do this as soon as possible. And for us to be able to do this, we extended this put method so that when another generic record, a nested generic record, gets into the record that we are manipulating, we convert that to a Spark row on the fly. So if it fails fast, it's good. If it does not fail, we don't have to go inside the record and unwrap everything, after the whole record is decoded. And we extended this specific data to, of course, when this is called by specific data reader, it returns our own records, not the Avro's generic one. So I get into, again, this is a developer's track, so we are going deeper and deeper. The last thing that I would like to show you is how this whole library, this whole architecture, those classes that we have been talking about, how those classes go inside Spark to make the conversion possible, okay? So again, we are referring to the two methods, to Avro, from Avro. So to implement to Avro, this is the signature for the method. So we have the data frame, receiving the data frame. We are receiving this schemas processor and an optional schema ID. And then we are getting a data set of arrays of bytes containing Avro data. So before we understand the whole method, it's important to mention that schemas processor is just an abstraction for whatever class that can create an Avro schema out of a Spark schema and vice versa. So this class must be able to provide schemas, Spark schemas and Avro schemas that are interchangeable in this sense, okay? So we create the encoder for Spark. This is important to do serialization, so I believe that most of you are familiar with this object. Then we go to each partition inside Spark, inside the data frame actually that we are manipulating. We get the schemas. For each of the rows, we invoke that whole architecture that we saw, passing the schemas and the schema ID. So if the schema ID is present, it's attached to the top of the payload. And this is the Confluent compatibility that Georgi mentioned. And why is this cool? This is cool because you may be able to change the schema on the fly. If it's backward compatible, you can change the schema on the fly. This is probably, in case the schema is present, it's probably being called from to Confluent Avro. But you think about it, for instance, you have a data frame, and you want to send this data to Kafka, and you have a consumer in another team. So what you do is, you call to Confluent Avro, the schema will be registered in the schema registry, the ID of the schema will be retrieved, it will be appended to the top of the payload, and then on the consumer side, the only thing that your consumer needs to do is point at schema registry, the schema will be downloaded in runtime, attached to your data frame, and you're ready to go. This is pretty much the idea. So talking about from Avro, this is like the dual method of that other one. So we receive the data frame and also the schema. So we have another layer that's called schema registry before this method was called. We get the encoder for the schema because Spark needs to know the schema. So it can do shuffling, for instance. Then we get the string version of the schema because this schema object is not serializable. And then for each partition, we create an encoder for this schema. It's another encoder that knows how to decode data from that specific schema, and we apply this decoder to each of the records that we have. So in this sense, we have binary Avro payload coming in, and Spark rows coming out. So to wrap up, what we expect to have been able to present here is we have tried to create this API that offers a seamless integration between Spark structured APIs and Avro data. And it has to support schema management facilities, and the schema registry is out there to support this management, and of course we wanted it to be part of the library itself. Also, it provides Avro support for Spark pre-2.4 that does not provide these to and from Avro as built-in features. However, our next step is to integrate with this Spark 2.4 so that it's like you can have a seamless integration. So if you're running Spark 2.4 and you have to Avro and from Avro, and at some point, okay, you're using Confluent platform, so you can use ABRIS and you can change without having to change your code. You simply put the library there and you're ready to go with Confluent. Or if you want to use schema management and schema registry, which is a very recommended thing to do, so you'll be able to do the same without having to touch your code. Also, this schema registry, it has some naming strategies which is related to how you store the schema, like the URL that you call to get the schema. So when we started to develop ABRIS, it was in the beginning of this year, the only strategy available was this topic naming strategy. But now, in July, they came up with 2 new strategies. So this record naming and also topic record naming. And we still do not support those strategies, but it's coming soon, as the slide is telling. So again, my name is Felipe. Georgi, my colleague, we work for ABSA. That's our GitHub space. So ABRIS space is that URL that you can see there. Feel free to go there to use it to submit any comments, critics, ask questions. We are happy to take those. And we are happy to take your questions now as well. Thank you very much.
Thank you, Felipe and Georgi. We only got 1 minute, so if you have a quick question and a quick answer, we'll take it. Anyone? Okay, I'll ask a question. What about if I'm a Python PySpark user? Can I actually use the Avro then?
So you should be able, because it's Avro in the end. Yes. So Avro, it has the same format. Mm-hmm. There should be no issue.
So I don't have to use fast. I don't have to download the fast package. I can just use the the ZA.ABRIS library to just do the conversion.
Yeah, should solve your issue. If it does not, just ping us.
Okay. Well, give a big hand to most.
Thank you very much.